Today, I'm going to talk about something called 12-factor agents, which is a set of essays that we wrote around mid-April, and we'll get into where it came from and how we got there. But first, and I'm not really going to talk about me and HumanLayer. I want to talk about us. Who here is building agents? Cool. Who here is using? Who here has tried using a agentic framework to build agents before? Leave your hand up if you're still using an agentic framework. Anyone building agents from scratch? Okay, cool. Good variety in there. The old question used to be, put your hand up if you're using LangChain, and then leave your hand up if you like it. But we're not here to bash frameworks. I'm actually, most of this content is really, if anything, is a list of feature requests or demands, depending on how loud I say them, of what I think agent frameworks should have and what they should enable us to do to build the AI applications of the future. So I think a lot of us have been kind of on this journey. You decide you want to build an agent, you do some design and product, oh, it should be able to do this, and it should talk to these services, and it should have tools, and it should do all these things. And you say, cool, let's go fast, let's get some tools off the shelf, let's get to building. And you get it up to like 70 to 80% quality, and you start to notice that like it's really hard to get past that. And it's also not good enough. It's good enough for demos, and it's good enough for messing around and maybe your own personal assistants and stuff. It's like, oh, this didn't work, but like I get it, and I know why, because I wrote the prompt, and I set up all the tools, and I know how to go fix it. But that like, if you really want to get to production-grade agents that are good enough to deliver as a product to charge people money for, you end up like diving deep into the call stack to reverse engineer the control flow, the framework, the prompts, how do these tools get serialized in, all that kind of stuff. And then a lot of people I talk to end up starting over from scratch. I've talked to probably 100 founders in the last 3 or 4 months, all shipping agents to the enterprise or to kind of like business critical use cases. And almost all of them are just building stuff from scratch. And we'll get into why and kind of what that means for 12-factor agents. There's another thing that might happen, which is you might realize that like your problem that you're trying to use agents for is just not a good use case for agents. I remember one of the first agents I tried to build last summer was, I said, has anyone ever used like makefiles for building projects? So I had a makefile and I gave my agent, hey, here's a list of all the make tasks you can run, go build my project. And it kind of worked, but it was doing things in the wrong order, so I kept making the prompt bigger and bigger. And I just spent like 2 hours on a Saturday messing with this. And I was basically got the prompt to the point where it was like, no, you have to run this one, and then you have to run this one, and then you have to run this one. And I like got up to take a break, and I was like, wait a minute. I already know the make file, and I know the order that the things are supposed to go in. I could have written that as a script in 30 seconds. Why are we using agents for this? If you already know everything that has to happen, that's just deterministic code. And we'll get into like what makes agents different and why we should want them and where they fit in. But basically the conclusions that I came to is like, there are some core things that make agents really, really cool. We've all used things like Manus, like, I don't know, name your favorite web app LLM thing that's like, this is magical. This is something different. And I talk to most people who say like, cool, we had software and now we're doing agents. And we're gonna throw out the old thing and we're just gonna do agents, and we have 7 agents and we're building agents. And I told them like, wait, you can just take small concepts and put them into your existing project and just make, because the best agents are mostly software. They're not give an LLM 1,000 tools and let it go run with it. We'll talk about why. And what I think is really cool about this is you don't necessarily need an AI background to build really cool agents or build really cool AI applications. And we'll get into some like simple concepts about why that's true. So, and this is all inspired, by the way, by a project from Heroku called the 12-factor app. About 15 years ago, before we had, today we call them like cloud-native applications or something like that. But Heroku was running around and they were trying to get people to use their platform, which was really, really cool, and realizing that like most people were building apps in a way that didn't fit with the Heroku way. And so they set out to say like, here's a bunch of things we've learned in the past 10 years of building services. And if you want to build apps that run nicely in the cloud, here's some things you should do. You should put your code in version control. You should have CI/CD. You should expose your web server on a port, which is like, now most of this stuff you see and you're like, yeah, of course I have a Git repo and I run my web servers on ports. But this did not used to be the obvious way to do things. And so that is kind of how we got to 12-factor agents. We wrote this all down after a lot of frustration using lots of frameworks and trying to build agents in lots of different ways. It is a open source GitHub repo. It's Apache 2. There's some code in there. It's Apache 2 licensed. I'll put this QR code up again, but please check it out. Give us a star. Give it a read. Throw a comment on there. Turns out a lot of other people had been on the same journey that I had, and it sounds like some people in this room as well, based on the hands raised. This was on the front page of Hacker News for all day. Something like 200,000 people looked at the LinkedIn post. It is flattening now, but we're going to change that tonight. But I hate, you want to compare it to other concepts, open frameworks in the agent world. That's model context protocol. So we can still keep. We got a big lead. We just got to keep it. There's 14 contributors from all around the globe who have added features and corrections and restructurings and improved the content there. It's really an open project that I really want to build and share with the AI agent community. And again, not here to talk shit on frameworks. I think the goal is like, what do builders need from the AI agent frameworks, and how can we serve them, especially builders who want to move fast, but they need a lot of control over what this AI stuff is doing. So what are you here to do? I wrote this slide in a hurry, apparently. This is proof that these slides are not AI generated, though, because Claude would not make that typo. I want you all to be here and question everything you know about agents. I would like for you to open up the black box a little bit and understand agents from scratch and build great AI applications with really strong engineering practices. So how did we get here? 60 years ago, we've been writing software for a long time. I haven't been writing software for a long time, but people have been writing software for a long time. And we're going to talk a lot about graphs. But at the end of the day, like, software is a directed graph. You have control flow that moves logic and state between different places. And maybe 20 years ago, we started having these directed graph orchestrators. If you know, anyone ever use like Airflow or Prefect or Dexter or anything like that? These tools where you get to model your code as a graph, and then everything runs as separate processes, and you get retries and resuming and all this stuff. It was kind of nice at the time. And the promise of agents was like, you don't have to write the graph anymore. You just have an event, you pass it into an LLM, you say, here's all the steps you could take, and the LLM will go figure out the order in which to do the things to solve whatever the problem is. And you just tell it what the goal is. Turns out this doesn't quite work. Has anyone tried doing this for like a complex workflow and it didn't work out? Do you mind sharing? What were you building?
For example, if you say, you know, build me a website, like a web application that does this, it just like, you know, makes a scrappy thing because it doesn't understand the higher goal.
And after getting a couple things wrong over and over again, it seems to just keep making the same mistakes over and over again, right? Yeah, that's just one flavor of why this falls apart. I like to think of agents is like, if you break open the loop, you're basically something's gonna start a workflow, and you're gonna ask an LLM, what is the next step? And we have some context object where we're keeping track of what happened. And if the model says it's done, then we return that final answer. Otherwise, we go run some other code. It could be calling another LLM, it could be calling a tool, it could be calling an MCP server, an API, or whatever it is. And then we append that, and we just loop until the model says it's done. So if I were gonna draw this, come on Wi-Fi, let's go. You know, you would have an event come in, you would determine the next step. Maybe you would call an API, you'd take that result and you'd add it to your context window, you'd feed it right back in, and then the LLM might decide it's time to kick off a pipeline. And then after that, the LLM might say, okay, now we gotta update some records in the database. And you keep looping through like this until the LLM says, like, whatever your initial event was, whatever the user's message was, whatever the crons told me to do, now we're done. And in that case, we would call the, how do we get onto the next slide? Come on. Ooh, boy. There we go. All right. Technical difficulties. Our materialized DAG here would be do those 3 steps in a row and then we get to the goal, but we didn't know that ahead of time. The LLM figured that out. What does kind of work in some places is what we call micro agents. I'm going to go through this part a little bit quickly. But we use internally at HumanLayer, we wrote a micro agent that does our deployments. So it's like mostly deterministic code, and then there's a really small agent that is only 10 to 20 steps in its kind of broader scope. So you're not asking it to go build a whole web app. You might be asking it to make a one-line change in code or something like that to compare to that other example. And then we run the deploy bot goes and asks someone for permission, and then we do the deploy, and then we run more tests, and then maybe we roll it back if it failed. But at the points where you want to collaborate with humans, that's where we see agents being sprinkled in really well. And so maybe we'll be able to get off the slide this time. So someone merges a PR to GitHub. We deploy that to our dev environment. We run the tests. We ask the LLM, cool, this has happened. Look at your prompt and decide what to do. It says, hey, let's deploy the front end. Human says, no, we got to do the back end first. We do the back end, that gets approved. So that actually gets executed and deployed. We pull that result on the context window and give that to the LLM. Now it says, cool, let me look at everything that's happened. Now it must be time to deploy the front end. It does that, and then it says, cool, we're done. And then that goes back into more deterministic code. And so the idea is that is a really small workflow. You're asking the LLM to do two things, but the fact that it's collaborating with a human in no way is a reason to basically make it an agent. Let's see, next slide. Cool, so this is this thing working in Slack. This is the exact example. Someone said, no, deploy the, I know it's pretty small, but this is me telling it to deploy the API first, then it goes and deploys the back end, and then it's coming back and trying to do the front end. All this is to say, an agent has 4 components. In this model, you have a prompt that is telling the agent how to behave, which tools to call, which tools are available. At a certain point, it's going to output JSON, which is just a structured object that says, here's what the next step is. And then your code is going to execute. And we call it essentially a switch statement or a big if-else of if the model said do this, then we go down this path. Otherwise, we go do something else. And then we loop until we get kind of a final answer. And we keep accumulating context along the way. Has anyone here ever written a for loop? What about a switch statement? Yeah, really hard advanced stuff here. I will try to convince you that you should just write the switch statement and the for loop yourself, because the hard part of this problem is in getting this prompt perfect. LLMs are just stateless functions, tokens in, tokens out, and so anything that gives you more control over the tokens that go into the LLM is going to give you more control over getting the best outputs, getting the best decisions. When you're 100 steps into a complex workflow, if you're able to get this working, it's because you're being very, very careful about exactly which tokens flow into that LLM at any given point. And so this kind of raw, just loop until you're done, here's 1,000 tools, figure it out. It can be made to work, but you need to take control, and you need to do some engineering to get there. And we're going to talk about how to do that. So these are the 12 factors. Number 1 is an agent is a thing that takes natural language and turns it into a tool call. Doesn't matter what you do with it, but you basically turn natural language into JSON that can be used to operate an API. Whether it's what's the status of my package, or read this email thread and update the CRM, or whatever it is. So if you had something like this, create a Stripe payment link for $750 for sponsoring some meetup, you would want to get this JSON out. What you do with that JSON is in a different factor. We're not going to talk about it yet, but just being able to turn intentions into structured data so that a computer, like a deterministic program, can use it. The other piece too is you should own your prompts. There's a lot of abstractions out there that let you have goals and personalities, and if you suck at prompt engineering, like I mostly do most of the time, this is kind of going to be helpful because it's going to take some basic strings and turn it into a really good prompt. You'd have to go to prompt school for months to get a prompt this good. But eventually, you are going to want to take full control, and you're going to want to write the entire prompt and do some weird token stuff and use XML over here and JSON over there and whatever works. And I don't know what is better in any given point for a prompt, but I know that if you have the flexibility to try everything, then you will be able to find what's best for your specific use case. Similar thing with context building. A lot of people say the only way to do a long context agent or even a medium small context is you have system message, user message, assistant message, tool calls, tool response, tool messages, and you kind of do it in the standard API format that is common across OpenAI, Anthropic, and all this stuff. There is no reason that you can't just put everything that happened so far in a single user message, format it however you want, and we'll get into why you might want to do this. It's I don't know what works better, but you need to open your mind to other ways to pass context to an LLM, and I think you'll find really interesting results. Has anyone ever done like putting all the context of an agentic history in a single user message? 1, 2. All right, we got a couple. If you do it like this. Yeah. And they changed something between GPT-4 and GPT-4o. I don't know if you noticed, but they changed the priority. If a tool response comes back with new instructions, the model will ignore it, versus if a user response comes in with instructions. So yes, definitely worth noting. But again, this is all just code, so you can track what's happened so far in model. This is Python. You can do TypeScript, whatever language you're in. You can just write however you want to serialize what's happened so far, send it to the LLM, and go from there. And your trace might look something like this, where you got a Slack message, and then it tried to deploy it, and then there was an error, and then it requested more information, and then someone responded. All your only job in relaying a context window is to tell the model, here's what happened so far, please tell me what the next step is. And I encourage you all, has anyone ever looked inside the token view for a prompt? Did it help? Yes? What did you learn? Yeah. Yeah. Has anyone ever just passed raw JSON into an LLM prompt?
If you use, instead of JSON, you use JavaScript, which is JSON without the quotes for the keys.
Yeah.
And you have fewer tokens. And the best is YAML.
YAML's very good too. This is the format I always use, and this is just based on vibes. I don't have time to do a lot of evals because it's mostly agents I built for myself and for our internal team. But we use this XML for the outer object and then YAML for the inner object. But if you look at this one, there's lots of quotes and like random parentheses and stuff like this. And some of these have meaning for the LLM, but it's a lot more tokens to focus on. And my buddy Vibov talks about this as like, it's like if the model is talking to someone who uses a lot of like likes and ums and ahs when they're talking. It's just a little bit harder to focus on what are you asking the model to do, what are you trying to convey to it. LLMs are pure functions, tokens in, tokens out. That's and this gets into like everything is context engineering. People make a big deal out of like prompt engineering versus memory versus RAG versus like the agentic history of your trace, which is what this section is about, versus like how you ask it to do structured output. Everything is context engineering. Everything is like, if you get the right tokens in, you'll get the right tokens out. And again, I don't know what's better, but the more things you can try, the more likely you're going to stumble into something that works way better than the naive default approach. Cool. Tools are structured output. Anyone remember this Dexter paper? Go-to considered harmful? All right, this guy's getting all my references. I like him. We're going to talk after this. There was this statement in C, and it still exists in a lot of languages, but it let you like jump around to different parts in the program. And this guy was a professor and a researcher, and he said, this sucks. This makes code unreadable. It's the wrong abstraction. Personally, I think tool use is harmful. And not that letting an agent use tools is bad, but that the idea that the agent is out in the world interacting with its environment, what's actually happening here is the LLM is outputting JSON, code is doing something with it, and maybe you go tell the LLM what happened, like if it's fetching a package status or something like that. This is it. There's no magic here. It feels magical because the people building those agents have done a lot of engineering to make it feel magical. So you can just write Python classes and ask the model to output Python classes, and then you can write code to handle whatever those Python classes are, or TypeScript or whatever it is. It's just JSON and code. Unifying execution state and business state, what step are we on, what's the status, what's the retry, all this kind of stuff, versus like, what's happened in the agent's workflow so far. If you can unify these things, you can simplify a lot. We're going to skip this video. Here we go. If you can basically have all of your state in one object in your program's memory, then you can do a lot of interesting things, at least at the start. You may get fancier. You may go get temporal or whatever it is to manage your business state someday. But when you're first starting out, you want to avoid big, heavy abstractions. Pausing and resuming with simple APIs. So basically being able to launch new stuff, being able to pause it, being able to resume it later. Let's say you have your determine next step function, and it has a bunch of tools. And something happens, whether it's a REST call or an MCP call, something invokes your agent and pushes some context in. It picks a long-running tool. You want to be able to interrupt and serialize that with some sort of ID that says, here's the workflow, here's the event we're handling, and then go launch that workflow. And then when it's done, you know, if we get a webhook back with that state ID, we can load that state back out of the database, and then we can append the result there, and then it goes right back into the model, and it can continue. And the model doesn't know that it's a different process running on a different server, whatever it is, because the state of your execution is just a string, or some slightly more structured, perhaps. But agents are just software, so let's build them like we build software, with REST APIs and with basic ways to store state in databases that we understand. Contact humans with tools. This one gets a little subtle, but if the user says something like, "What's the weather in Tokyo?" you're asking it to make a really specific decision for that very first token, which is like, am I going to output text to the user, or am I going to output something in JSON and call a tool? I think a lot of people have found, a lot of people I've talked to is like pushing that emphasis of that first token choice down a little bit, forcing it to always call a tool, and having the decision about which token to output be either check the weather or request clarification. Again, you don't have to have the model output text to return text to the user. You could say, oh, the model output the request clarification tool. We're going to show that in the UI and get the clarification and push that back in the context window. I think everybody I've talked to who's building really powerful agents is doing this. So there's some stuff here. I'm not going to go into this. You all can read the repo goes into a lot of depth of like how you would basically use webhook handling to get this stuff back. And this lets you build what I call outer loop agents. I think the ChatGPT style interface where there's a human sitting at the console all day and like asking a question, model works for a while and then gives you a response. That's pretty cool. But what I think is actually really cool is agents that can be proactive and agents that can work asynchronously. And they're going to contact humans with tools, and they make work multiplayer with lots of different humans. And again, I don't know what's better. You may find you get better results if you ask it to output the final answer kind of just string type token. But you should probably try everything. Again, owning your control flow, bringing your own switch statement. Again, switch statement, not a hard thing to write. And then you can sprinkle in all kinds of fun stuff like LLM as judge and summarization and break pause for input. And I know there's ways to do this in like more graph-driven frameworks, but code is a graph. So if you like writing code, just write code. I'm not going to go super deep on that one. This is an intro to 12-factor agents. Building great agents requires a lot of flexibility and creativity. Don't box yourself into a specific model where like all your functions just have to be named entities in a map that gets looked up by some loop that you don't control. Telling the model about when it's screwed up. Let's see. If we determine next step and then we go try to handle it and it fails, you can take that error and you can put it on your context window. This is not novel. I'm sure lots of people do this. Lots of frameworks do this by default. The idea is you don't have to do this. And you don't have to do this in exactly this way. Or you can only do this. You could have a completely deterministic software that in its error handling will ask an LLM, oh, what should we do differently? And again, this is the idea of like you can take these concepts. If you use a framework, you can get all this stuff kind of baked in for free or like most of it. But you don't need to switch your paradigm. You can just pick up little concepts and build them into software that you already have. I'm having bad luck with the videos today. So what about spin? Has anyone ever done this and seen the model just make the same mistake over and over and over again? Yep. So you can be really like, how do I say this? The way you fight spinouts is you own your context window, and you don't keep if the model keeps making the same error over and over again, then you don't tell it that it made that same error over and over again. You kind of clear it out. If you're 5 errors deep, you kind of clear it out. Maybe you rewind your context window. If you control an object in memory that is like, here's what we're showing to the model about what happened, you could serialize it in different ways depending on how deep in an error spinout that we are. If you have a bunch of errors and then you get a valid tool call and it works, you should remove all those errors from the context window and pull that back up so that they're not clouding the model's understanding of what's happening. You can summarize and redact those errors. You can limit the number of loops that you go through, the number of like consecutive errors that are allowed. And you can do small focused agents. This is the biggest one, is if your agent is only expected to do 10 to 20 steps, it's a lot better at recovering from errors than an agent that hits an error 80 steps in and then tries to go resolve it. And a lot of people ask me, like, okay, sorry. I moved these slides around right before this talk. So small focus agents, around 100 tools, around 20 steps, feels about right now. As the models get smarter, and we'll talk about what happens when the models get smarter, but you want to keep that context manageable. Has anyone done like the Gemini long context thing, where you just stuff everything into a giant context window and try to get it to solve the problem? A couple nods, okay. I think that works, but I don't think you'll find anyone who will argue that like the smaller and more focused your prompt is, the better results you're going to get, no matter what. And I think this gets into like what happens when the models get smarter in general. Is here's my take: is you may have this big deterministic workflow today, and you may slowly sprinkle in these micro agents into parts of it. As the models get smarter, maybe they can handle bigger. Maybe it goes up to 500-step workflows. Maybe it stays around 30. I don't know. But the point is you can keep moving forward to give them more and more responsibility. But one of the big takeaways here, and this is someone from the Notebook LM team said this, I think it's perfect. It's like the only way to build really magical experiences in AI is to find something that the model is like barely capable of. It's right at the boundary of the capability, and then you get it right consistently. And that boundary is going to move as the models get smarter. But there will always be an advantage in knowing the engineering principles that allow you to get the most out of whatever the smartest model today is. Trigger from anywhere, meet where users where they are. Basically, I don't think that I should have to go to 6 different web apps to use 6 different agents. I should just be able to email with all of them, or Slack with all of them, or text with all of them. Let's see. And then, yeah, this one's a bit of a meme, but like, you're gonna need functional programmers in the house? Or perhaps React developers who still on the Redux train. We use that, actually someone tweeted at me, it's actually not a stateless reducer, it's a transducer, because there's multiple steps in the workflow. But basically all an agent is something that takes a current state of the world, decides what to do next, makes some changes to that state of the world, and then loops through. And that the agent itself should be totally stateless, and all you're managing is this kind of serializable context window. So yeah, agents are software. You can write a switch statement. You can write a for loop. LLMs are stateless functions. Put the right things in, you'll get the right things back out. If you own your state and your control flow, you can do really fancy, interesting things like pause and resume and replay and forking from history. Go find the bleeding edge. Find something that models can barely get right and figure out if you can engineer your way into an agent that can solve it consistently. And I think agents are better with people. And so there are hard things in building agents. You should probably do them anyways. And a lot of what we do at HumanLayer is open source, because I think it's important that we solve this together. I do have a business around this, because some of this stuff is hard and interesting, and some of it is hard and boring. And we don't think you should spend all day wrangling like email workflows and Slack webhooks and things like that. So we have this business on the side where we're trying to take some of the hard but boring stuff off of the plates of agent developers. Somebody I worked with for a while, he put it as basically like most AI tools try to take away the hard AI parts and make that part easy for you. And what I really want is, this is his words, is like, I want tools that take away everything else. So all I focus on is the hard AI parts. All I focus on is getting the prompt right, getting the tool calls right, and being able to get the most out of the model. So I think that's it. I hope this was fun. If I've done my job, you'll be stoked to fire up an editor and go write some code and build your own switch statement, build your own for loop. And if you want to come riff about agents, I'll be here all night. I'll be the tall guy with the weird mustache. I should be easy to find. Thank you all so much for watching and for coming out tonight.
Thanks for the talk. I was surprised you didn't appear to mention the architecture where the LLM creates a plan and then launches this focused agents, which basically, because planning appears to be kind of working. So on the high level, these models appear to say roughly which steps need to be done. And then individual steps is kind of like what you mostly discussed here. So do you have an opinion on that kind of architecture?
Yeah, I mean, I think basically the idea is by removing the black box, you can do whatever you want. You can make the determine next step be 3 prompts to 4 different models, and then you go execute the next step. It's all just code. If you look up, like, a lot of these models will try to implement, a lot of frameworks will try to like implement the AI paper for you and say like, look, we have a planning agent and we have a tree search and we have all these different like Monte Carlo like planning system, whatever it is. It's like, no, that's the hard AI parts. That's what you should own. Is someone who's trying to build applications that deliver business value, you figure out if planning works better or not. So yes, a lot of papers say planning works better. I've seen some cases where it actually makes things worse. And the idea is like, this is not about agent architectures or specific agent architectures. This is, if you own the core loop of your agent, you can build whatever you want.